Greetings, chemistry students, and today we are writing names for ionic compounds that contain polyatomic ions. So recall from when we looked at types of compounds that we were looking at some polyatomic ions. You can find the polyatomic ions that we're using in this class at the back of your chem helper. And so that's the little reminder that I have written for you at the top of our page right here. So if you need to pause this video in order to go get your chem helper, please go ahead and do so, because otherwise this is going to be really, really hard. You need to flip it over to the back so that the periodic table is actually facing like the table side. And if you look all the way to the right hand side, you're going to see a box that says common radicals, and then under that in parentheses polyatomic ions, and it's a long list. And the ones that I have here, because I wasn't able to make a really good picture of your actual chem helper, but a lot of the polyatomic ions that I have here in my table, like in this table, are very similar to the ones that you have there. So I just thought it would be easier and more clear for you to see this copy instead of a copy from your actual chem helper. But recall that a polyatomic ion is simply a group of atoms that are bonded together and that share a common charge. So some of our polyatomic ions have a positive charge. For instance, over here, like this one here, this is ammonium. So what this means is that one nitrogen bonded to four hydrogens doesn't have a neutral charge like a compound would. Instead, it has a +1 charge. Like if we took away one of the hydrogens, because hydrogen has a +1 charge, and we had the compound NH3, which is ammonia, that's a compound because it's neutral. But by adding that fourth hydrogen there, we have created an ion called a polyatomic ion, and its name is ammonium. And then down here at the bottom, we have a lot of anions that are polyatomic ions. So how can you tell just by looking at a formula that you have a polyatomic ion? The easiest way, you guys, is look for the number of capital letters. If you only have 2 capital letters, that means that you don't have a polyatomic ion. But if you've got 3 or more capital letters in your formula, you definitely have a polyatomic ion. And in order to name it, you've got to flip that chem helper over so that you can actually find the polyatomic ion. So if I'm taking a look at my first example here, we have H3PO4. The first thing that I'm going to do is name my cation. Well, that's going to be hydrogen. It's on the left. It's right here. So hydrogen is my cation. So I'm first going to write the name hydrogen. And then I'm just going to cross it out. And I'm going to cross it out along with the subscript of 3 that's next to it, because we don't need it for naming ionic compounds with polyatomic ions. But look at what's left. What's left here is PO4. So again, because I have more than one capital letter, I know this is a polyatomic ion. So I've got to go to my table and find PO4. And when I do, it's right here. It's PO4. We have a -3 charge. That's nice to know at this point. It's not something that we have to know right now, but you can see that this is called the phosphate ion. Well, I'm going to drop the word ion, and I'm just going to write the word phosphate. And there it is. There's the name of my compound, hydrogen phosphate. And I'll take away my scribbles so that you can actually see it. But that is hydrogen phosphate. Let's do a couple more. If we take a look at number 2, you can see that once again, we have our cation. It's on the left. We have calcium. I'm going to cross that out, and when I do, look at how many capital letters I have. I have 2 more. Now, if I had only 1 capital letter, then that's an element. Like, I would just look for it on the periodic table itself. But if you look for NO3, you're not going to find it. So we need to find NO3 here on our chart, and here it is right here. NO3 is called the nitrate ion. You're going to drop the word ion and just write in the word nitrate. Our next one, we have MgOH2. Well, Mg, magnesium, is our cation. I'm going to cross it out and check it out. I still have 2 more capital letters, so I need to look at the back of my chem helper and find the name for OH. OH, let me just erase this notation. OH is right here, and look at the name, hydroxide ion. But again, go ahead and drop the name ion, and then you just write the name hydroxide. Great. Okay, our last one. Here we have our first element that's on the left. This is aluminum. I'm going to cross it out. And then I have what's left. I have Cn. So if I find Cn on my chart here, I can see, here it is, it's cyanide. So the name of that compound is aluminum cyanide. So that's how you use your chart on the back of your chem helper in order to help you name these different compounds. Now, I just want to draw something to your attention. If you take a look at all of the names of these ions, most of them end in ate, or they end in ite. Where's my other ite? Over here. But there are some of them that end in IDE. The one that you're mostly going to find ending in IDE, like the one that we're going to use the most, is hydroxide. And just like we did here, cyanide. And you just have to remember, so if you've got the name of an ion that has IDE or IDE at the end, sometimes it will be on the back. If it's hydroxide or cyanide, certainly it's a polyatomic ion. But remember, when you're just writing binary names, all of them end in IDE. But if you can't find hydroxide on the periodic table, then please remember to flip your chem helper over so that you can find it on the back. But most polyatomic ions have names that end in ate, ATE, or ite, ITE. So if you have the name of a compound that ends in ate or ite, flip over that chem helper so that you can find the formula there. All right, everybody, good luck doing this. Check your work against the key, and I'll talk to you again soon.